Alright, so I got assigned for my pencast homework 1, question 34, and the question is, what are the sound intensity levels I for sound waves of intensity, which is beta, of 46 decibels and 103 decibels? So to begin, we're just going to write the equation that relates I and beta, which is as follows: 10 decibels times the log base 10 of the sound intensity over the smallest sound intensity there is, which is equal to 0 decibels, which is also equal to 1 times 10 to the negative 12th work per meter squared. And so that's the value we're going to be using, since dividing by 0 would give you a non-finite number. And so we're going to solve this algebraically to begin with, and then just provide the solutions, because it's really just plugging in the numbers and into a calculator. So the first thing we're going to do, or the goal at least, is to isolate I. And to do that, we first divide by 10 decibels here. And beta is also in decibels, so these units will cancel out. So we get beta, which is in decibels, over 10 decibels. Those cancel out. And that's going to equal log base 10 I over I naught. And so now, using properties of logarithms, we're going to isolate this and get rid of the logarithm and make it an exponential function. And so to do that, we know that this 10 here represents the base, this represents the exponent, and this represents the solution to the base and the exponent together. So what we get then is 10, the base, times, or raised to beta divided by 10, and that equals the solution, which is I over I naught. So the next thing we have to do is to multiply I naught to both sides. So we're going to multiply by I naught, multiply by I naught, and we get I equals I naught times 10 raised to beta over 10. And so now we just simply plug in 46 and 103 into beta, and we get that 46 decibels is 3.98 times 10 to the negative 8th work per meter squared, which is the units of intensity. And then we find that 103 decibels corresponds to 2.00 times 10 to the negative 2nd work per meter squared. And so these are our solutions. And that's how you solve question 34 from homework 1.